Okay, functions and graphs. Remember that this is when you're going through the My Math Lab homework. Remember that the goal is not to sit there and try to figure out how to answer the question. The goal is to know how to answer it, and it's testing you on if you know. You know what I mean? Like, I don't want you to train yourself to work through the My Math Lab questions without actually knowing what you're doing, just to get a check mark. Because then when you get to the test, it's not going to stop you to say, hey, that wasn't right, or, oh, you left the parentheses out or something. So make sure that you're treating the My Math Lab, I guess, like a quiz, like an open note quiz, and you're trying your best to know how to do it without relying on the prompts in My Math Lab, okay? The 1-2 notes that we started, we were talking about functions and graphs, and then we were evaluating them. We were evaluating them from a graph, or we were graphing it. We got to this one right here. Go to this slide. Let's make a note. In here, this, by the way, is called the radicand. You may recall that vocab word from geometry or algebra 1. It's called the radicand. The D on the end is silent. It's not radidont, it's radicand. Ha, ha, ha. It cannot be negative. The radicand cannot be negative, like the overall, okay? So the goal is, when we're getting to domain and range, the goal is to recognize, oh, that's a square root. What's the rule in math with square roots? You cannot take the square root of a negative. You might think, well, yeah, you can, and then you get imaginary. We're staying in the real world, no imaginary. So as of right now, you cannot take the square root of a negative, which is why this graph has this abrupt cutoff, because it's anything from -4 and this way is allowed to be plugged in. Like if I plug 9 in, 9 plus 4 is 13. The square root of 13 can be evaluated, right? It's a decimal. If I plug 1 in, 1 plus 4 is 5. The square root of 5 can be evaluated. If I plug -4 in, if I plug -4 into the function f, it would look like this. -4 plus 4, which is what, y'all? And what's the square root of 0? 0. So can it be evaluated? Yes, which is why it's right here. Now, if I plug -5 in, I get the square root of -1, which is a problem, right? This is a problem. I should put the X there. Let me do this. This is a problem. Can't be imaginary. We're not dealing with imaginary right now. We're staying in the real world. So, -5 is not allowed to be plugged in because it's not in the domain of the function. Which is why if you go to your calculator and you type that in y equals and then you go to table, you are going to see the word error on all the numbers that are less than -4. And that's because they yield negative numbers. Let's practice this slide. Okay, for the function f of x equals x squared minus 6, use the graph to find each of the following function values. Use the graph. Where's the graph? Oh, wait. No. Who has a textbook? I wonder if I just forgot to copy the graph. You really don't. No, you just plug it in. 6. Oh, there's the graph. Okay. So there's two ways to do this. The directions are saying to use the graph, but because they give you the function, you could just do what with it? Plug it in. Look, when it says find each of the following, when it says, oh, that was bad. Stand by. When it says find the following function values, that means plug it in. It means evaluate it. So you could go ahead and evaluate this. You're plugging -3 in for this one. You're plugging 1 in for that one. And while you do that, I'm going to pull the graph up to show you how to also do it with a graph. Two ways to do this. It's just asking you to, they're giving you the function, they're giving you the equation, and then it's saying use the graph to find the function values, which means I'm giving you x, they want you to state y. Okay, two ways to do it. If you have the function itself, you can just plug it in. So there's, we'll make a note, two methods. Method 1 is evaluate, and by that I mean plug it in. Plug x in. They give you x, it's right there, f of -3. Don't forget parentheses or you'll get it wrong. So if you plug it in, you come out to 3, right? So the y coordinate is 3. I think that's what they want you to type in MyMathLab. They don't want you to type the coordinate point. The second method is use the given graph, which is a lot faster when the graph is given because they're going to, it means that the point that you're looking for is going to cross the grid in the background perfectly. So if you look, we're trying to find out where's the graph when x is what? -3. So you go to the picture, you find on the x-axis -3, and then you either go up or down depending on where the graph is. In this case, you go up, and it's right here, and you read the y-coordinate. The y-coordinate is 3. That is the coordinate point right here, -3, 3. That's how you read it. It's as simple as that. So what is the y-coordinate when when x is 1? -5. That's it. Which brings us to something that you should recall. Right there, did this. Can I change the screen? The vertical line test. Y'all remember that? If I give you, so when we started these notes, I was giving you real world problems and saying, hey, is this a function? Then I was giving you, coordinate points, right? And they were called relations, and you had to determine if it was a function. You checked to see if the x value repeated. Now I'm going to give you a graph, and I'm going to ask you to tell me if it's a function, which brings up the vertical line test. Remember, it's the same, you're looking for the same thing that you did with the relations. You're looking to see if the x coordinate repeats. So the way to check if an x coordinate repeats is to drop a vertical line, vertical because that would be the x, like, you're checking all the x values with a given vertical line. And you just trace in your mind the graph, and you make sure, like, so far I'm good, right? I'm good. But right there is where I experienced the first issue. And then from here all the way to here, I have issues. Because it's crossing the graph in multiple spots. To give you a visual, if we were to look at the T-chart of those points, we've got 3, -1, we've got 3, 2, and we've got 3, 5. So do you see how the x coordinates are repeating? And that's a problem. Like this means not a function. So instead of listing the t-chart, you just look at the graph and you check and see, does it cross your vertical line only one time throughout the whole graph? And if it does, then it passes the vertical line test. See, these are problems here and here, or even if you dropped one right there. If you dropped this vertical line, which I think is where it was intended to drop, right there, these are problems. Can't have that. Okay? So now go to the next slide and practice it. This is just a real quick yes or no. Look at the next 6 graphs and write yes or no, Y or N, as to whether the graph passes the vertical line test and is a function. I think everybody's had a chance to try it. So if it passes the vertical line test, it is a function. So what do you get for A? Yes. B? No. C? No. D? No. Those are obvious. E? Yes. F?
Yes.
Y? Okay, so this is yes. We're going to make a note. Watch out, and I'm putting B/C for because. If both, try not to write too much. If both points, and I'm going to just draw a closed circle, then no. So the answer was yes, but if right here, if that had been closed, if it looked like that, then the answer would be no. Even something as simple as that single little point, had it been closed, then that means if I drop the vertical right there, then I have an X value that's repeated, and that's not good. So you have to check those to make sure that only one of them is closed. Can they both be open? Yes. Remember, open means it's not actually touching that value. It's getting really close to it, but it's not touching it. All right. Now let's talk about domain and range. Go back to chapter R, where I gave you a rational expression like, I don't know. Some of you got this wrong on the exam, so I need you to make sure that you understand it now. All right, so look at this. If I say to you, what is the domain restriction on that equation, you have to ask yourself, the first question is, what type of function is it? Because if it's linear, 2x minus 1, that's linear. What's the domain restriction? There isn't one. It's just a line. It can, at any point, any number you pick, you can plug it in there, you're good to go, right? If it was quadratic, there's no domain restriction. Any number you pick, you can plug it in there. This is not linear, this is not quadratic, this is starts with an F, not 4 letters. It's another F word. Fraction. It's a fraction. So you have to ask yourself, what's the rule in math and fractions? What can you not do? You cannot have 0 in the bottom of a fraction. That's the rule. If you will ask yourself that, and then answer, by saying, oh, it's a fraction, then you should say to yourself, I cannot have 0 down here. That cannot equal 0. Then that's going to guide you to what your domain restriction is. So that means any number can be plugged in here except what would make the bottom 0. What would make the bottom 0? -4. So the domain here is all real numbers, but there is a restriction that x can't be -4. We did that in chapter R review. It's going to come up again here. Look at the first one. When we do domain, a lot of times people either really get it or people sit there and struggle with it because they just don't understand what domain means. 3. We will have 3 types of functions where you have, 2. We will have 2 types of functions where you have to be careful. Meaning all the others are all real numbers. The 2 that you have to be careful are when it's a F word. Thank you. It's a fraction, or it's a radical, a square root. Square root. Now, it can be a cube root. Can you take the cube root of any number? What's the cube root of 8? What number times itself is 8? Like 3 times. 2, right? Can you take the cube root of -8? Yeah, what is it? It's -2. So cube roots are fine. They look like they would be more challenging. They're not. It's because it's an odd number of times, which is totally allowed. It's when it's a fraction, the F word, or a radical, a square root. Square root, okay? Those are the 2 that you have to stop, wait a minute, look at it. There's a rule. And you have to ask yourself, what's the rule? So let's look at this. Find the indicated function value. What does this mean? We already talked about it earlier. What? Yes. It's as simple as that. Plug it in. Find the indicated function values. This means plug it in. If possible, it says if possible because it could be a number out of the domain, and determine whether the given values are in the domain. That sounds really complicated. Basically, plug the number in. If you get an answer, it's in the domain. If you get an error, it's not in the domain. Does that make sense? It's as simple as that. Did I get an answer? Then it's in the domain. Did I get an error? Then it's not. So let's look at this one. It says to find f of 1. Okay, so 1 over, I'm plugging a 1 in right there, right? So 1 minus 3. 1 minus 3 is -2. Did I get an answer? Yes. So this is, 1 is in the domain. Because I came to an answer. What about 3? Minus 3 is 0. You better not go to your calculator and try to divide that. You better memorize this little poster right here. And I'll probably take that down at one point to see if you memorize it. Remember that it's okay for 0 to be in the top of a fraction. That's okay. It's 0. It is no-go when 0's in the bottom. That means undefined, which means error, which means is 3 in the domain? No. Okay, you try B. What'd you get for G of 16? And what was your answer? By the way, the fact that they changed it to G just means they're naming this one function G. It doesn't mean anything. Alright, what about -7? When you plug -7 in, right there, you have a problem. This is a problem. I'm just going to write error. You cannot take the square root of -7. We're sticking to real numbers. So because that right there is a problem, then the answer is no. -7 is not in domain. Can you tell me what is the smallest number possible that I could plug into that function G and it would be okay?
1.
What? 0. Think about it. Square root of 0 is, which is allowed, and then +5, that's a number. Smaller than 0 would put you in the negatives, and as soon as you go to plug it in, you have a problem. So 0 is the smallest number allowed to be plugged into that function, which is bringing us to where we're going right here. Okay, so we have 4 practice problems, and I added this with, please tell me it's in here. Go to the next slide. Good. Okay, good. All right, so I added a 5th one because I was trying to give you one of each. So that way when you go to practice, you can't say, you didn't show me how to do this one. I'm about to show you how to do all of them. Look at A. The directions say find the domain. Make sure you're reading the directions. It's not asking you to solve. You can't solve. It's not asking you to evaluate. It's simply saying find the domain, which means, I want you to write this, ask yourself, what are the restrictions? What are the restrictions? And then I'm running out of room. Here are the only 2 types of restrictions that you're going to come up with. The F word, can't have what in the bottom of a fraction? Can't have 0 in the bottom of a fraction. And then square roots. Cannot have a negative under the square root. Those are your only 2 restrictions. All of the others should be all real numbers. The only ones that you have to stop and say, wait a minute, I gotta actually do some math here, are when it's a fraction with x in the bottom, because that means there's a number that can't be plugged in, or when it's a square root. Which is exactly why I added the 5th example here, because you will see no square root here. So I was trying to help you cover all of them. Okay, look at the first one. Function F. You should already be able to do this. It is from chapter R. Try it right now. Find the domain. And then I want you to write it in the interval notation. State the domain, write it in the interval notation. And then technically you should be able to do B from chapter R as well. So at this point, if you don't have an answer that's already starting to like form on your paper, then I want to help you, because by now you should be almost done with A or done. you look at the function and you say to yourself, Ms. Holcombe said there's two things I have to be careful for. A fraction when there's an x in the bottom, or a square root. Which one's this? That's a fraction. So I want you to make a little note. This is me trying to take notes so that your mind will start to think this as you're practicing this. This is a fraction, and then you need to remember that the denominator cannot equal 0. That is going to guide you to the domain. If the denominator cannot be 0, you need to state then what's off limits. So you go to the denominator. It's a little counterintuitive to what you think. Because the denominator cannot be 0, you go to the denominator, you set it equal to 0, you solve it, and then you say, hey, that number's off limits. In this case, you can solve it visually, but let's act like you can. You set the denominator equal to 0, you solve, and then you say x cannot be that. And then you look at it, check it. If I plug 7 in, I definitely would have 0 in the bottom, and that's a problem. Now you're going to visualize a number line completely shaded. Yeah, visualize a number line completely shaded, but there's a gaping hole on what? 7, on what's off limits. If you need to draw it real quick, it doesn't have to be fancy or Picasso. I did. I haven't written it yet. No. So the parentheses. Okay. So if you draw the number line, then this is going to guide your interval notation answer. Any number is allowed to be plugged in except 7. Think to yourself, what's to the left? Negative infinity. What's to the right? Infinity. There's your intervals. So what's the domain? Always read from left to right. Negative infinity to 7, hop over that, and then 7 to infinity. And that's the domain. Now, you could list it as set notation, but MyMathLab wants interval notation. Okay? So, if you're not comfortable with it, now's the time to get comfortable. Now let's try B. You should already know how to do this. I'm not asking you to tell me if there's a hole or if it's an asymptote. I'm simply asking you to tell me what's the domain. So since it just says what is the domain, then the top of this does not matter at all. Because the bottom of the fraction, whether there's a hole in the graph or it's an asymptote, the bottom of the fraction is going to cover the both of those. Okay? Does that make sense? So you focus on the bottom. I'm going to write focus on the denominator. Remember, it cannot equal 0. So set it equal to 0 and solve it. It is a quadratic with 3 terms, which means it check to see if it'll factor to a binomial times a binomial. This should be a short and sweet one because, why is this one short and sweet? Because recognize when A is 1. Remember, and I'm going to put it in green. When A is 1, you can go straight to parentheses. Okay. If A was not 1, like in the top of it, let's pretend the top had been in the bottom, you'd have to do the whole X, come up with your numbers. Alright, so I still draw the arch because I don't want anyone to ever forget that A times C part, in case A is not 1. Alright, 1 times negative 3. Negative 3. What are the factors of negative 3 that add up to positive 2? 3 and negative 1. Because A is 1, I can go straight to parentheses. I can't stress that enough. Because A is 1, I can go to parentheses. So it's going to be x plus 3, x minus 1. Now, you've taken the denominator, you've set it equal to 0, you've written it in factored form. Look at this, y'all. This is the zero product property. You have some crap. What's this mean in the middle? Times some more crap, and it's equaling. The only way to multiply two things together and get 0 is if one of them is a 0, right? And could they both be 0? Yeah, right? 0 times 0 is still 0. So the only way for that to happen is if one of them or both of them is 0. So you have to figure out then what are the x values that would make it 0, which is why you pull them apart and you set them equal to 0 on their own, and then solve those. But remember, domain. So what we just found was off limits, right? Sketch your little number line. Put these numbers on there. Obvious holes on those numbers. The rest will be shaded every time. Everything else is allowed. Then fill in your negative and positive infinities. And now translate it to interval notation, reading it from the left to the right. So from the left, my domain is negative infinity to negative 3, hopping over negative 3 to 1, hopping over 1 to infinity. That big U, if you remember from like day 1 or week 1, that means union. It just means, hey, I'm not done, there's some more. There's some more shaded sections. Okay? When look now at A and look at B. The work we did. They're the exact same thing. The only difference was B was a trinomial that had to be factored. A was just a binomial, and it was easy to state what's off limits. Those are the same thing, same approach, okay? Now go to C. Don't overthink this. What did I say are the only two you have to stop and be careful about? The F word and square roots. What do you have here? This is a what? This is a cube function, and then what's this? This is an absolute value function. Are those one of the two words that I said to be careful for? Nope. Which means, are there any numbers off limits here? Nope. So if there's no numbers off limits, imagine your number line. What's allowed? There you go. All of them. So let's make a note. Neither are fractions, square root. So you have this big old number line, the whole thing is shaded, which translates to your domain is all real numbers. Any number you pick, doesn't matter what it is, you can plug into that equation and you will get an answer. And because you get an answer, that means it's graphical, which means it is any, like, no numbers off limits. Any number you want can be plugged in. So what looked like probably the toughest problem in here actually turns out to be one of the easiest. Because I've already told you, the only two that you have to stop and work are if it's a fraction or a square root. Which brings us to D. And what is D? That is a cube root, not a square root. That's a cube root. There are no restrictions with cube roots, and that is because it's an odd root. So even if the number underneath was negative, that's okay. So what is your domain? Your domain, I'm just drawing it again to kind of train you to think, okay, so the whole number line's okay, which means negative infinity to infinity. And then I would like you to make a note, because it's an odd root. It's the only reason this was all real numbers is simply because we had an odd root. Which brings us to, what if it's a square root? That's why I put this next one in your notes. Chase. Mr. Sabota needs to see you at the end of class. Okay, what if it's a square root? So look at this. Find the domain. I just copied the directions. This is a square root. So I want you to write, watch out. I just on road ahead. I'm just kidding. Square roots cannot have, I'm writing a full little sentence, negative radicands. This is what your mind should be trained to think. I have a square root, I can't have a negative radicand. Now, this one's a little different than the whole fraction technique. Can't have negative, right? Correct? Okay, I want you to visualize the number line. What's to the left? Negatives. What's to the right? What's in the middle? Okay. What's allowed? Or? Sorry, it's just natural. Like, you say that? Okay. So, close. So the way think to yourself, what's allowed? We know negative is not allowed, which means 0 is good or positive is good, right? I'm writing notes as I'm talking out loud. 0's allowed, positive's allowed, yes? So you're going to take the radicand, and this is where you want to write steps for square root domain. Like if it's a square root function and you have to find the domain, here's the steps. Set radicand. It's got to stay positive, and it can also be 0. So you set the radicand greater than or equal to 0. Solve. And that's your domain restriction. Radicand, by the way, is the stuff that is underneath the square root. Just the stuff under the square root. Okay? So pull the radicand out. X plus 2. Now it's not equal to 0, that's a fraction. It's got to stay positive or it can be 0. Right? That means greater than or equal to 0, which means the value of this equation, this expression, has to stay higher than or equal to 0. Visualize the number line. So you're calibrating. You're saying, hey, it's got to be to the right or at 0. Can't go negative. So solve it. Subtract 2. So x has to stay what? Greater than or equal to -2. Draw your little number line if you need to. Probably don't need to now that it's an actual inequality. Yeah, I haven't written the what's it called, the interval notation yet. I was showing the process because we're gonna have more complicated expressions. Does that make sense?
Yeah.
Yeah. All right, so we're at -2 or higher, so the domain is, no, what needs to go here? A bracket. I changed colors so you'll pay attention that it's different, right?
So why is this one different than
A
what
was
could an A be? Like the bracket
that one,
A with this, not that
because
one.
that's a fraction. There's only one number off limits, and that's 7.
You can please figure out these other options, please.
Yes, you can have negatives in the bottom of the fraction.
Other things.
You can't have negative underneath the square root. Let me throw one thing on here just in case my math lab throws it at you. Would my answer change from this had my equation had this at the end, but on the outside of the radical? Would my answer change? No. If there's something on the outside of the radical at the end, it's a moot point. Doesn't matter. It's like a cow's opinion. It's moot. Because what matters? What's underneath the radical. So should there be something at the end, you ignore it. It's only what's underneath the square root that is the restriction. Jason, don't forget to go